All right, so let's plot a couple of points. Who doesn't really understand the plotting points part very well yet? Anybody? Speak now or I'm not going to do it. Everybody understands plotting points. Okay, red one. How do I plot minus 5 pi over 3? Okay, wait. Everybody stop, because I only want red one to answer. Y minus pi over 6, red one. What quadrant is minus pi over 6 in? That's the question, yes. So, okay, I see what you're saying. So pi over 3 is in quadrant 1, right? So we'll call this pi over 3. What is it in the third quadrant? Good, 4 pi over 3. Perfect. So now we're at 4 pi over 3, so we're here. And then I go 5 out. 1, 2, 3, 4, 5. So this is my point, minus 5, comma, pi over 3. Good job. Oh, that was you, Damien. I asked you not to answer. I was asking red one. So guys, please, if I ask somebody, if I name somebody, please don't other people answer. I'm trying to find out what everybody knows, not just what the people who know. Okay? You understand, Damien? But I'm happy that you know it. Trust me, I'm very happy that you know it. But I don't know now if red one knows it. Okay, red one, you get to do B. Only red one. Okay, how do I do B? What quadrant is 135 degrees in? Nope. Red one, why do you never come see me in office hours? You always come to my office hours? I'm not talking about class. You do always come to class. Come see me separately. You stay away. Don't stay away. We need to get to 135 degrees. Who doesn't know where 135 degrees is? John, where's 135 degrees? Quadrant 2. This is 90. This is 180. This is 135. Okay. Okay, let's move on. So these are the points that it was graphed. This would be what polar paper actually looked like. So this is all here up online for you if you want to look at it. Let's continue. So now we want to be able to convert from polar to rectangular. We just converted from rectangular to polar, right? Now we want to convert from polar to rectangular. Well, if we look here, we can see that if this is the reference angle right here, and this is x, and this is y, then I can say that the cosine of theta is equal to x over r, can't I? And the sine of theta is equal to y over r, right? Just from our picture, just from trigonometry, right? Does everybody know what I'm saying? Okay, hopefully that's a yes. Okay, good. So that means that x, or our rectangular coordinate, is going to equal r cosine theta. And our y is going to equal r sine theta, isn't it? Just from trigonometry. There's nothing new here. That gives us our reference angle. Of course, we have to put it into the right quadrant, but at least we know how to find our reference angle. So we're going to convert from polar to rectangular form for these two problems. And we don't need a calculator. So we want to find, this is r comma theta, and we want to find x comma y. Okay, so let me see who's next. Michael T. All right, how do I find x, y for A? X equals r cosine theta. So x equals r cosine theta. What's r? 12. Cosine, and theta is 5 pi over 3, right? So what's the cosine of 5 pi over 3? What quadrant? No. What's the reference angle? Nope. Okay, so this is 0, this is pi, this is 3 pi over 2, this is pi over 2, right? So 5/3, is that more than 1 or less than 1? Okay, so 5 pi over 3, if you want to know how to find what quadrant change it into mixed numbers. 5/3 is the same as 1 2/3, right? Yeah, it's going to be in quadrant 4. Because 2/3 is more than 1/2, and 1 is more than, yeah. Okay, quadrant 4. What's the reference angle? Okay, red one. I'll give you another chance. Let's let Michael answer these. Pi over 3. Good. What's the cosine of pi over 3? Is it positive or negative in quadrant 4? It's positive. Good. So my x value is 6. My y value, thanks, Michael. Red one, stop. Okay, Michael. Y is going to be the sine of 5 pi over 3, right? What's the sine of 5 pi over 3? That's 3 over 2. Good. Is it positive or negative in quadrant 4? Good. So this is equal to 6 minus 6 rad 3. Okay? And those are our xy coordinates. So it would be 6 comma minus 6 rad 3. Good? Any questions about this? Because x is equal to, so let's say this is theta, right? And this is x. This is y, and this is r, right? I'm sorry. Sorry. I feel like it really helps, though. Does it really not help? Y'all are young. Y'all's heart can take it. I mostly care about your brain at the moment. Right? I mean, if anybody's got heart issues and you're really afraid to be called on, let me know. But otherwise, I think it really helps in the long run. But I know I know. Listen, I do it every day. Yeah, R is always a hypotenuse. See, y'all judge me for making a mistake, and look, it's hard. I do this every day. I don't come in with the answers. I do them with you. Okay. Oh, I was answering the question. Sorry. So, whose question was it? Oh, Damien. So, Damien, are you on a regular computer? Is it better? Is it plugged in? Or are you on wireless? Okay, okay. So your connection's solid. Okay, good. I'm glad. It's good to have you here. Yeah, so if you have a triangle, let's say you have a triangle, right? And here's theta, here's x, y, and r. What's the cosine of theta? Here, we're up here. Cosine is not opposite. Cosine is adjacent. Yes. It's x over r. Think about it. Cosine is the x value, and y is the sine value. Yeah, adjacent over hypotenuse. Good. So I multiply both sides by r, and I get x equals r cosine theta. No worries. Okay? Okay, good. Makes sense is the actual wording I like. Do you want to should we do B, or do you kind of get this? Well, I would imagine it does at the beginning of the semester. I'm trying to have thetas not be bad at the end of the semester. Okay, I'm going to clear this page. Does everybody have what they need? Okay, there we go. Boom. Okay, so now we have 6, 240, and I want to know what is x, y. How do I find x, y? Let's see, who's next? Okay, Red One, I'm going to give you this one, but then you have to stop answering when I call on other people, okay? Okay, so we are in quadrant 3. What's the reference angle? How do you find the reference angle, Red One? The reference, that's a value. So what I need is the reference angle. So the angle is theta equals 240. That is, where's my, oh, there it is. That's the reference angle. 240 is that, right? This is 240. I'm asking you, what is the reference angle? The reference angle is just this part right here. Nope, that's not the reference angle. The reference angle is just this angle right here. Okay, what don't you get? The reference angle is the angle that the terminal sides makes with the closest x-axis. I don't know a better way to say it. So, if this is 180, we're in degrees now. You have to answer in degrees. If this is 180, and this is 240, what is the reference angle? Yes. Yes, the reference angle is equal to 60 degrees. Okay, good. You don't have to be sorry. So the reference angle is equal to 60 degrees. Now I want to know, I need to figure out what x and y are. How do I do that? I have r and theta. R equals 6. Theta equals 240. How do I find x and y? How do I find x? X equals what? That's true. That's true, you're right, although it's r squared, not r. Except that doesn't help me because I only know r and I have two variables there, right? So that won't help me. What's another formula that we have? We could, but yes. Oh, now we're praying. Okay. Yeah, Griffin.
Could you do the r cos theta equals 6?
Yeah, r cos theta equals x. And y equals r sine theta. So we have r is equal to what? No. Yes. R is 6. What's the cosine? What's the cosine of 60 degrees? One half. Is it positive or negative in quadrant 3? Negative. So that equals -3. See? It's harder when you're on the spot, isn't it, red one? So now we have r is equal to 6, and then it's the sine of 60 degrees, which would be rad 3 over 2. In quadrant 3, it's negative, so it equals -3 rad 3. And that would be the equivalent x and y. Make sense? Any questions?